To start chapter 2, we're going to start looking at measurements, taking correct measurements, reading correct measurements, and today we're going to really focus on converting measurements. So when I say to convert a measurement, what does that mean? You have any idea what that means? Otherwise called unit conversions. Any idea? Yeah, right. I could take hours and put it in minutes, right? Or I could take inches and put it into centimeters. So when I do unit conversions, am I changing the measurement at all? No, I'm just changing the way I express it. So 1 hour is exactly the same as 60 minutes, right? It's the same amount of time, right? Just like 1 inch is the same as 2.54 centimeters. It's the same length. It's just expressed in a different unit. So as we start looking through these unit conversions, you need to understand when I say convert this to this, right? I'm not changing the value of the measurement. What I'm changing is the way in which I'm expressing it. Okay, so as we go through unit conversions, you need to be thinking about that. Okay, I'm not changing the measurement. I'm not changing how much of the substance there is. I'm changing the unit at which we're writing it. Okay, or by which we're writing it. So that's going to be our main focus today. So to start, we are going to be using the metric system, right, or the SI system, and they use 7 different measurement units, and I'm going to give you just basically the big ones that you need to make sure you have kind of memorized, and then there's a few extra. So I'm going to put them all up here on the board, and I want you to write them down, and then we'll talk about them a little bit more. Okay, those are the big 4, and then there's maybe just one other. I guess I took the other 2. Okay, so go ahead and get those written down, and then we are going to talk about what they mean. Okay, we have meter, second, Kelvin, mole, and then we have kilogram. What do you think that the unit for mass should just be? Gram, right? Kilo is a prefix, okay? The reason that kilogram is what they call the base unit is because grams is such a small unit of mass measurement. Okay, when we measure anything in kind of real life, it's going to be in a larger quantity than just a gram. So they use kilogram as their base unit. Okay, kilo is what we call a prefix. Can anyone give me a couple others examples of metric system prefixes? Yeah. Yeah, like a kilometer too. So kilo goes with meter, it goes with liter, it goes with gram, it goes with second, right? What are other prefixes besides kilo? Centa, good. What are some other ones? Kilo, centa, milla, right? Millimeter, milliliter, okay? Decimeter, okay? We're going to go over all these metric system prefixes. But do those at least sound familiar? Have you heard the metric system before? Okay. All right, so these are our metric system prefixes. And this is the table that I'd like for you to have in your notes. I formatted it in a way that I want you to pay attention to. I formatted it in a way so in this column, we always give the larger unit the 1. And that's how I'll do a lot of my conversions. So the larger unit gets a 1. So all of these units are larger than what we call the base unit. And the base unit can be meters or grams or liters or seconds or whatever measure we want it to be. But the larger unit always gets the 1. So in this example, I just gave meters as an example. It could be megagrams equals 1 times 10 to the 6 grams. It could be kiloliters equals 1,000 liters. Okay, so I need you to understand this example column doesn't only apply to meters. It applies to any other unit we have. Okay? And I always give the large unit the 1. So 1 meter equals 100 centimeters. That would also mean 1 liter equals 100 centiliters. Okay? So go ahead and get that chart copied down. And I just need you to understand that the right-hand column is just an example in meters. It applies to every type of measurement. I really want to point out again that that column on the right-hand side is just an example for meters, okay? It can be liters or seconds or grams or whatever it is. So if I ask how many grams are in a kilogram, what are you going to tell me? If I ask how many grams are in a kilogram? 1,000, right? And if I ask how many milliliters are in a liter, what are you going to tell me? If I ask how many milliliters are in 1 liter, what are you going to tell me? 1,000, right? Here's milli. So there's 1,000 millis in the base. Right? Okay. Is there anyone that's not quite seeing that? If we needed to find area units, right? When you find the area of something, you take length times width. So you take the length unit, which is usually meters, times the width unit, which is meters, and you might get meters squared. Volume is measured in liters or milliliters. Okay, and this is important right here. 1 milliliter is equal to what we call a cubic centimeter. 1 milliliter is equal to what we call a cubic centimeter, so a centimeter cubed. These two units mean exactly the same thing because because milliliters and cubic centimeters mean the same thing. Okay. Temperature is not going to be measured in Fahrenheit. It's going to be measured in Celsius, right? That's kind of our scientific temperature unit. And if it's not going to be in Celsius, it's going to be what we call Kelvin. Have you heard of Kelvin before? Have you worked with Kelvin? Okay. Converting from Celsius to Kelvin is an easy conversion. Okay, we won't ever deal with Fahrenheit temperatures. The conversion from Fahrenheit to Celsius is much more complex. The conversion from Celsius to Kelvin is really easy. Okay, so if I have something that is, to convert from Celsius to Kelvin, all I'm going to do is add 273. Okay, so if I have 0 degrees Celsius, that means I have 273 Kelvin. Okay, that's all I do is I add 273. Okay, so that means if I want to go from Kelvin to Celsius, what should I do? Yeah, I subtract. Okay, so let's try one here. If I have, let's see, I'll just ask it up here. Convert 25 degrees Celsius to Kelvin. Okay, and Kelvin doesn't have a degrees. We don't call it degrees Kelvin. It's just Kelvin. Right, and I didn't make that rule, but that's just how it goes. Okay, so convert 25 degrees Celsius to Kelvin. Okay, what did we get? 298 Kelvin. Okay, so that's just how we say it. We have 298 Kelvin. That's our temperature, 298 Kelvin. So if I said convert 200 Kelvin to Celsius, degrees Celsius, yeah. Okay, go ahead and do that conversion. What should it be? Negative 73 degrees Celsius. Right, so Celsius can be negative. Kelvin will not ever be negative. Okay, if we reach 0 Kelvin, that's what we call absolute zero. Right, and we're long gone by that time. It's way too cold for us to live at that point. Okay, 0 Kelvin would mean everything in the universe comes to a stop. Right, molecules, atoms, everything come to a stop at that point. So that's no good. Right. So that's called absolute zero. You might want to write that down, okay? So if something were to reach 0 Kelvin, that's called absolute zero. Okay? Way too cold. Yeah. Are ones that take us from the U.S. system to the metric system. So we use pounds a lot. We use inches, feet, ounces, right? These are the things on the left that are U.S. system measurements. The things on the right are metric system measurements. So those are things that you need to have. Okay, you need to have these conversions down. So these are called conversion factors. So if I ask for the conversion factor between inches and centimeters, you're going to tell me 1 inch equals 2.54 centimeters, right? That's the conversion factor. And that's what number that allows us to convert from inches to centimeters or centimeters to inches or whatever it is, okay? So we're going to use these numbers to help us take units from one to another, okay? You'll notice that both of these units are length measurements, right? Feet and inches. So if you're going to memorize one of them, just pick one, and then you'll be able to always convert length from US to metric. And these are both mass units, so pick one of them, right, and memorize that. You don't have to memorize every single thing on this table, right? If you know that a pound equals 0.45 kilograms, then you could always, kind of narrow it down to that and then go backward to what you need. So we'll walk through that as we go, but you don't have to worry about memorizing every single thing on this table. Okay. So the reason we use units, right, with carrying our units is extremely important. It not only tells us what was measured, right, but it's so important that without a measurement or without a unit, right, we don't even know what happened. We don't know what this value is for. Okay, measurements are just numbers without a unit. Okay, so carrying our units through our entire problem is really important because it shows us what was being measured the whole time. On your answers, you cannot leave plain numbers. Okay, numbers have to have units. All right, we are going to try some conversion problems here, so you need your calculator, okay? So the first thing we're going to do is we're going to convert some using the system that we know best, right, using the U.S. system. So these are conversion factors you probably already know, right, how many inches are in a foot, things like that. So 36 inches to miles, we're going to use something called a T-chart system to help us with unit conversions, okay? Or sometimes this is called dimensional analysis. And what it is that we're using our units to help us work our way through a conversion problem. So we're going to convert 36 inches to miles, okay? So before you even start this problem, we want to record a 36 inches, right, that's it, into miles. Should we be expecting a really big number here or a really small number? A small number of miles, right? 36 inches is a fraction, a really small fraction of a mile. Would you agree with that? So we should be coming out with a small number. So before you start conversions and as you are working through the problem, you should be thinking about the fact like, okay, I should be expecting a small number here. And if it doesn't come out that way, we need to make sure we're checking something, okay? So this is how a T-chart system works. You start by writing what you know. I know I have 36 inches. So we write 36 inches, and then we draw our T. Okay? So to go from inches to miles, what do you think the sequence needs to be? From inches to what? Inches to feet, and then feet to miles, right? We don't have to go to yards in between. We don't have to do any of that stuff. Does anyone know how many feet are in a mile? Almost. 1 foot is 5,280. Oops, 1 mile is, sorry. 1 mile is 5,280 feet. Okay, so if you don't have that memorized, you need to have that in your notes. Okay, and like circle it or highlight it or something because you might use that pretty often. 1 mile equals 5,280 feet. Okay, so we know we need to go from inches to feet and feet to miles. So when we're using this dimensional analysis or this T-chart system, we need to make things cancel because essentially this is one big fraction. Okay, we're kind of multiplying a bunch of fractions here. So if I want to get rid of inches and go to feet, right, I want to convert from inches to feet. I need inches to go on the bottom so that it cancels and feet to go on top, right? If I want to cancel something in a fraction or in an algebra problem, it's got one has to be in the numerator and one has to be in the denominator. Would you agree with that part? Okay, so that's all I'm doing here, okay? And so in the conversion factor between inches and feet, which is the larger unit? Feet, right? So I give the larger unit the 1, and I say how many inches are in 1 foot? 12. Okay? So now I've canceled my inches units, and I'm not going to do any math until I get all the way done with my conversion problem. I'm not going to plug anything into my calculator until I get everything into my T-chart. If I stopped right now, my unit would be feet. Okay, is that what unit I want to be in? No, I want to be in miles. So I'm going to add another section to my T-chart. Okay, I want to go from feet to miles. So feet needs to be opposite of where it is now. So I go feet to miles. Right, and we just talked about the conversion factor between feet and miles. So 1 mile is equal to 5,280 feet. Okay, within these sections of our T-chart, we're not doing any math. We're just putting in conversion factors. So we're saying 1 unit of this equals X units of our other one. Okay, so we're not trying to do any math ahead of that point. Okay? One of the units always is going to get a 1. Okay, so if I stopped now, I'm done with feet, I'm done with inches. My unit now would be miles. Is that what I want it to be? Yes. Okay, so now to complete this problem, I multiply across the whole top, divide by the whole bottom. Okay, multiply across the whole top, divide by the whole bottom. So I take 36 times 1 times 1, right? You don't have to plug that into your calculator. It's just multiplying by a 1. Then we do divide by 12, divide by 5,280. Okay, or in your calculator you could do divide by parentheses 12 times 5,280, close parentheses. There's 2 ways you could do that in your calculator. Okay, in my calculator I like to just do this. 36 divide by 12 divide by 5,280, right? Because these are both in the denominator. Okay? You could also do 36 divided by 12 times 5,280. Right? You could do it that way in your calculator. So we got, I got it to come out at 5.68 times 10 to the negative 4th. Right? Does your calculator say e negative 4th at the end? Okay, that means times 10 to the negative 4th. How many of you feel pretty good about scientific notation? A couple of you, okay? For those of you that are unfamiliar with scientific notation, we're still going to get to that point. But what this is saying is that we have a really small number. And some of your calculators might have given you the number that looks like this. Okay, either of those answers is acceptable because they mean the same thing. So did we get a really small number like we were expecting? Right, we expected our number to be really small. Do you have a conversion? Do you know what the conversion is from ounces to pounds? There's a direct conversion, and this is a U.S. one, so you guys should know this one, I think. 1 pound is equal to how many ounces? 16, good. 1 pound is equal to 16 ounces. So if I want to go from 38 ounces to pounds, I write what I know and I draw my T. Okay, I want to get rid of ounces and go to pounds. So where in my T chart does ounces need to go? Opposite. So it needs to go on the bottom. And I can go directly to pounds. Right? We said there's a direct conversion there. So we said 1 pound is equal to 16 ounces. I'm done with ounces. I'm left with pounds, which is exactly what I wanted. So all I'm left with to do there is the math. 38 divided by 16. 2.375 pounds. Milligram to kilogram. Milligram to kilogram. So some of you might have learned the ladder system at some point with the metric system. I don't use that. If you're comfortable with that, you are more than welcome to do so. But I will always use that T-chart system when we do conversions. So if you're comfortable using the ladder system and just moving the decimal place, that is fine with me. Okay, but you have to show your work as you're doing it, because if it's wrong, then it's just wrong, and I can't give you any credit, any partial credit for that. Okay, so just make sure you are paying attention in that. Okay. So, if we want to go from milligrams to kilograms, can we go directly there? Or is there somewhere we got to go in between? Milligrams to grams to kilograms, right? We know how many milligrams are in a gram, and we know how many grams are in a kilogram. We don't have to stop at every place in between. Okay? To the base and back should be kind of the system that you go with. Okay, to the base and back. So when I say base, I'm talking about grams or meters or liters or whatever it is. It fits right there in the middle of your chart. Are you seeing that on your metric system chart? Right, there's a break in the middle. That's your base unit. Okay, so that's where grams in this case fits in. Okay, because we don't have anywhere on that chart how many milligrams are in a kilogram, right? You know how many milligrams are in a gram, and you know how many grams are in a kilogram. Okay, so that's going to be our process. So we're going to go 142.2 milligrams, and I draw my T. Okay, so if I want to go from milli to the base, right, from milligrams to grams, that's what my T chart needs to look like next. I'm getting rid of milligrams, and I'm going to grams. Okay. I think it's easiest if you fill in your units first and then put in your numbers. Okay, so then we say which is the larger unit here? Grams. So grams gets the 1, right? The larger unit gets the 1. Then we tell how many milligrams are in a gram. And what are you going to tell me with that? Check your chart. Check your table. How many milli is in the base? In your example, it was meters, right? But it's the same exact thing. Right, it could be grams, could be liters. So how many milli goes in the base? 1,000. So check your table and see if you figure out where we're getting that 1,000 from. Okay. So I'm done with milli. If I stopped right now, what would my units be? Grams, which is not what I want. Right? I want to go from grams now to kilograms. Okay. And which unit is larger between grams and kilograms? Kilo. So I say 1 kilogram is 1,000, right? Does everyone agree with me that it's 1,000? Are we seeing that in our table? Okay. So I'm done with grams. Now I'm left in kilograms, which is exactly what I want. So you need to do the math here. See what you get. All right, we multiply across the whole top, divide by the whole bottom. Raise your hand if you agree. Yeah, or it could have looked like this, 1.422 times 10 to the negative fourth. Right? Is that what we came out with? Perfect. That's what we should have had, a small number here. With metric system, I know if you're unfamiliar, it's harder to predict if you're going to have a big or a small number. That's okay. Okay? But we should be able to figure out that it's going to be a small number, right? A milligram is a really, really, really small unit, and a kilogram is a huge unit. So as we go from milli to kilo, we should think about, okay, we're going to have a fraction of a kilogram here. So that's where we have a really small value. Okay, questions so far? All right. Let's try just this first one. How many centimeters are in 0.48 kilometers? Okay, so we write what we know. It's probably good for you to start thinking about what's the path I'm going to take. So to go from kilometers to centimeters, I'm going to go kilometers to what? Meters to centimeters, right? If you look at your chart, you don't have a direct correlation or a direct line from kilometers to centimeters, right? Go to that base unit, meters or liters or whatever it is, and then go to the next one, okay? Is that part making sense? So I'm going to draw my T, right? I write what I know, draw my T. I'm going to go from kilometers to meters. Okay? What numbers need to go in this section of my T chart? Good. The 1 goes with kilometers. And how many meters are in a kilometer? 1,000. Good. So it's really important you understand it's not like 1,000 always goes on the bottom or 1,000 always goes on the top or whatever it is. That's not the rule. The rule is that you follow the units. Okay, so I wanted to get rid of kilometers. It had to go opposite. Now I want to get rid of meters. So where does it need to go? Opposite. And I want to go to centimeters. Now you fill in your numbers. So once your units are correct, then you fill in your numbers. So which unit between meters and centimeters gets the 1? Meters. Good. And how many centimeters are in 1 meter? 100. And that comes directly from your table. Okay. So I've canceled meters. I've canceled kilometers. I've left in centimeters, which is exactly what I want. Right? So what's the last step here? Do the math. Yep, multiply. So I multiply across the whole top, divide by the whole bottom. Okay, and the whole bottom is 1, so I don't even have to do any division. Right? I'm just going to multiply that. Should we be expecting a large number or a small number? Large, right? You're going from kilometers to centimeters. We want to find out how many centimeters are in about half of a kilometer. Okay, yeah. Okay, try the next 2 of those on your own. This is nanometers. Okay, really small unit. And this is milligrams to megagrams. Okay, so I'm seeing a little more stumbling on this one than I was hoping, but that's okay. We're going to go 3.2 megaliters. Okay, our steps from megaliters to milli have to go mega to the base to milli. Okay, are we understanding that part? All right, so mega, if I want to get rid of megaliters and go to liters, that's what my units need to look like, right? 1 has to be in the numerator, 1 has to be in the denominator in order for me to cancel. Does that part make sense? Right? We want to cancel them out. So I've got to get them in the 1 in the numerator, 1 in the denominator. Which is my larger unit here? mega. So mega gets the 1. Okay, looking at your table, there is 1 times 10 to the 6th liters in a megaliter. Okay, 1 times 10 to the 6th. That was the very first one in that chart. Mega is the biggest unit I gave you. 1 times 10 to the 6th. Another way of saying that is a million. Right, so that's 6 zeros. Now I've canceled mega, and I need to go from liters to what? Liters to milliliters. Okay, which of those is the larger unit? Liters gets the 1, and there are 1,000 milli in a base. So I'm done with liters, done with megaliters. I multiply that out. Multiply across. Stop right there, okay? We're done, and we're left with the units that we wanted to get to. So we just stop. We don't do any extra math, right? We put every conversion factor in, and then we do our math one time. Okay, so I do 3.2 times 1 second E6. Right? You can still use scientific notation when it's in the numerator. Times 1,000. Are we getting a really big number here? Okay. 32 with 8 zeros. 1, 2, 3, 4, 6, 7, 8. Right? Or it might have also come out in your calculator 3.2 times 10 to the 9th. Okay, or 3.2 E9. Okay, did anyone get that? Or no? Yes? Okay. If that's what you had for your answer, I want you to raise your hand. It doesn't give us a number to start with, right? How many are in a leap year? But what do we know about a leap year? There's an extra day. So how many days are in a normal year? 365. So in a leap year there are 366. So that's what we're going to start with. 366 days. Okay, so to go from days to seconds, what do you think our path is going to have to be? Days to what? To hours, to minutes, to seconds. Okay, I think you can do that one on your own.